Hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it. This is Radical Equations Part 1, which I guess is the easier version, or the easier part, because I'm imagining Part 2 is probably harder. So if you are looking for Part 2, that is the next video. You'll be able to see a description for that, or you can just go to the playlist for all the algebra Kuta software worksheets and click on that playlist and you'll be able to find part 2 in there if you're looking for part 2. But anyway, so part 1, we want to solve the equation, which means we want to get x or m or whatever the letter is. We want to get the letter by itself, right? That's always the goal when you're solving any equation. And the other thing about solving any equation is it's sort of like the opposite of simplifying. When you simplify, please excuse my dear Aunt Sally, parentheses, exponents, multiply, divide, add, subtract. You're probably familiar with that, right? Well, that's for simplifying. That's for simplifying. Simply. I can spell. Hold on. Simplifying. So when you do the quote unquote order of operations, you're simplifying. You're trying to get a bunch of numbers to turn into one. When you're solving, you're trying to get rid of numbers, not try to consolidate them. So if I spell PEMDAS backwards, it spells SADMEP, right? Like a Dr. Seuss character. He's a sad mep. Oh, the meps that are mepping and they're all sad and I don't know. I can't Dr. Seuss. But sad mep, opposite of that, right? So solving. This is for solving. And the other thing that is the key to solving. So there's two tricks to solving. One is there's an order of operations for solving, sad mep, the opposite of PEMDAS. And then two, you do the opposite operation. So the opposite of plus is minus, the opposite of times is divide, and the opposite of powers are roots. All right, and that's a square and a square root, but it could be other powers. It could be a cube and a cube root. In this case, it looks like, at least for right now, they're all square roots. So here's how you do number 1. Square that, square that. X equals 100. That's it. That's the answer to number 1, right? It's really that easy. Now, of course, as we go on with this worksheet, it will start to get harder. There's a lot to be more steps. But that's where the SADMEP thing comes in. So you use SADMEP in conjunction with the opposite operation. You do the opposite of the thing that's happening to the variable, and that gets rid of it. If you do the opposite, opposites cancel. Okay, so for number 2, what's the opposite of a square root? It's a square. Square, square. 100, right? 10 squared. 100 is equal to, well, the square and the square root cancel again. So m over 10. Now I'm not done. So this is the first time that that's happened, right? When number 1 was just one step, that was it. Now we have 2 steps. So you know how in PEMDAS, where inside of the parentheses there's another PEMDAS? Another PEMDAS? Well, inside of the parentheses in SADMEP, there's another SADMEP. SADMEP. So what just happened here was the m over 10 was like stuck inside of a parentheses. Now a square root is technically not a parentheses, but it is a way to group things. Anything under the square root is all grouped together. So sometimes I call it SADMEG, G for grouping instead of P for parentheses. But it's all kind of in a parentheses, even though you're not actually putting parentheses. It's all grouped together. So you have to get rid of the thing that's holding it all together, right? AKA the E. We did the E step. and then that unlocked what was underneath the radical, and then we look at what to do inside of the radical, which is to multiply both sides by 10. Okay? So that's why sometimes it'll seem like things are out of order. They're not out of order. You'd follow SADMAP and it will not steer you wrong. You might just have to do a parentheses and then do SADMAP all over inside of the parentheses. Once you square both sides, you start SADMAP all over again. And really PEMDAS too. You'll see that later on as well. Oh, and by the way, 10 times 100, right? That's just 1,000. No big deal, only 1,000, right? Yeah, only 1,000. No big deal. All right, number 3. Square, square. V minus 4 is equal to 9. Now notice that was squaring, right? So we squared both sides. That was the E step in SADMAP. But then that unlocks the grouping, the parentheses, right? The invisible parentheses that's holding the V minus 4 together. So then I add 4 to both sides, which would be this A step over here. Right? So V is equal to 13. All right, and same thing for number 4. Square both sides. That cancels. 6 squared is 36. It's equal to V minus 2. And then I add 2 to both sides. Here we go. And 38 is the answer for this one, right? And that one wasn't really that different from 3, so it didn't really, spend too much time going over that one, but kind of starting to get the hang of this, huh? Then we move on. And looks like we have largely the same stuff for right now. Let's go ahead and change colors, though. Largely the same stuff. This is actually the same as number 1 here. It's a one-step equation. I think they just wanted to kind of trick you because 9 has a square root, but you're not squaring it. Or not square rooting the 9. You're squaring it. So just be careful. Don't take the square root of a number just because you can, right? I think that was maybe why they chose the 9 there for that number 5. All right, square both sides. So it's 25 is equal to x plus 3. Because remember, the square root and the square cancel. And then we subtract 3. 25 minus 3 is 22. All right, not bad, right? Okay, square it, square it. 4 is equal to 4b. Divide both sides by 4, and b actually equals 1. Which, actually, if you plug it in, it makes sense, right? If b is 1, if you plug it back into the equation, b is 1, okay. 1 times 4 is 4. The square root of 4 is 2. Yeah, that works. And the other thing, too, that I haven't mentioned so far is you might be wondering, oh, yeah, but don't you plus or minus when you take a square root of both sides? I don't know if you remember that trick. And yeah, the answer is yes. But if you square both sides, you do not do a plus or minus. We're not square rooting both sides. There's already a square root there. We're squaring both sides. You don't do a plus or minus. You only need to do that plus or minus if you're going to square root both sides of the equals. So be careful with that if you were wondering about that one. So n plus 9 equal to 1 because 1 squared is 1. And then I subtract 9 from both sides, I get negative 8. Right? Always be careful with negative answers when you're solving radical equations because you can't take the square root of a negative number. Now, I didn't say the answer couldn't be negative, but you just want to be careful. If you get a negative answer, maybe plug it in just to check. All right, I think I would highly, highly recommend that. I give that like a 9 out of 10 recommendation. If you get a negative answer, check it for 2 reasons. One, it might be what's called an extraneous solution, meaning you didn't do anything wrong. You did all the math right, but you plugged it back in, and then somehow something weird happened and you got a negative. That happens sometimes. It's called an extraneous solution. It just means that the number didn't work out. You did all the math right, but the number just didn't work out. That's all that is, right? It's just sort of one of those anomalies. The other reason you might want to check is if you get a negative answer, you might have done something wrong. Like you might have done some math wrong somewhere. Maybe, right? So that's the other reason why you would check it. So if I plug in negative 8 plus 9 is 1. Square root of 1 is 1. All right, so we're good to go. Number 8 is good to go. All right, moving on to number 9. Looks like we're ramping it up a little bit here, so we definitely want to change colors to show that we're ramping it up here. So this time, this is the first time this has happened, by the way. The square root is not by itself. It's negative 8 plus a square root of blah, blah, blah. Blah, 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 blah. And then that's equal to negative 3. So now, what I want to do is I want to, remember earlier it was sad mep, right? So I'm going to redraw it, sad mep, and then inside the parentheses, oh, I was going to write PEMDAS, not PEMDAS, sad mep again. You might need to do some simplifying, but I don't think we'll need to just yet. Not until we get to some of the later ones, some of the last questions in the worksheet. Okay, so let's use number 9 with this golden sad mep here, and let's run through the list. Can we subtract s on both sides? The answer is no. Can we add? Yes, we can add 8. So we can't add or subtract anything inside of this square root yet because it's trapped. It's trapped inside of a grouping, or you can call it a parentheses. It's not like technically right, but you can call it whatever you want to. So now we have this, and negative 3 plus 8 is 5. Okay, we did A. A is done. Can we divide? Can we multiply? No and no. Can we exponent? Yes, we can exponent. We can take the square of both sides, and now see we're back to what we were doing for the last 8 problems. Square both sides to get rid of the square root. 5a minus 5 equals 25. All right. I'm going to need to make another little space right here to finish solving this equation. But there we go. We just did the e. Now we've unlocked a parentheses. And now we start over with sad mep. Can we subtract on both sides? No. Can we add? Yes. We can add 5 to both sides. If I add 5, the minus 5 goes away here. And I add 5, right? Add 5, that goes away. Add 5 to 25, I get 30. Okay. So A is done. And then can I divide? Yes. I can divide by 5. Divide by 5. A is equal to 6. Whew. Okay. So we got A is equal to 6. And then you can plug it back in to check it. For harder questions, I would maybe say give it a 5 or a 6 out of 10 recommendation that you would check it. Not necessarily right after you're done, because it's kind of a long problem, so it'd be even longer to check it. But maybe like star it, and then if you have time during your test or quiz or whatever, come back to it later and check it. So I'd give it like a 7 out of 10 recommendation if this is on a test or a quiz. If you have time, go back and check it and plug it back in, see if it works. Just to make sure you did the math right, just to make sure there's no extraneous solution, all that kind of stuff. Okay, number 10. We're not going to do the sad map because I've marked up my sad map over here, but we're going to still follow sad map without actually circling and crossing out as we go here. So we would, can we add? Can we subtract? No, no. Can we divide? Yes. Divide by 10. Square root of 9x is equal to 6. Square, square. 9x equals 36. Okay. Little dividers here. And then we just divide, here, I'll just rewrite it. And then we divide by 9. Boom, boom, we get 4. All right, and that's it. 9 times 4 is 36. Square root of 36 is 6. 6 times 10 is 60. Check, check, check. Plugged it back in, it works. All right, same thing for 11 here. Let's see, square, square. 1 is equal to x minus 5. Add 5 to both sides. And you get 6. That wasn't as bad as number 9 or 10. That was a little bit easier. It was a little bit lighter there. Okay. What about this one? Divide by negative 10. Okay. V minus 10 equal to 6, square, square. V minus 10 equals 36. V is equal to 46. And there we go. That is it. All right. And that was another 4 problems. So now we're moving on to another color and maybe another trick. They might throw another trick at us here at some point. That was like a gold. That was meant to be like a yellow, but yellow's kind of hard to see, so I usually use gold instead. So now we're going to switch to an orange. And let's see, minus 10, minus 10. So now we do that, and we get 10m minus 1 equal to 3. Square both sides. That cancels. 10m minus 1 equals 9. Then we would add 1 to both sides, divide both sides by 10, and we get 1 for a final answer. Looky there. So now we're going to divide by negative 6 for the next one. We get 2. Square both sides. 4 is equal to b plus 4. If we subtract 4 on both sides, b is actually equal to 0. Looky there. I kind of want to check that. If b is 0, you would do 0 plus 4 is 4. Square root of 4 is 2. 2 times negative 6 is negative 12. Yeah, that works. All right, we add 1 here. So v plus 3. Add 1, we get 8. Square both sides, and you get 64. Subtract 3 on both sides, and you get 61. There we go. All right, divide by 9 on both sides. Square both sides. Divide both sides by 25. And we get 4. All right, not bad, right? It's not getting too much harder, I don't think. If you think it's getting a lot harder, let me know in the comments so I can make sure I slow it down a little bit as I'm going on the next one, because there's another part 2, that I'll be doing next after this. So let me know. But here we go, square, square. This is the first time it's got a square root on both sides. Now this one isn't that bad because it's a square on both sides. So square root, we square, square, and then it cancels. So it cancels it on both sides. Later on though, when there's not a square root on both sides, it'll get a little bit different. And you'll see what I mean in a little bit here. So we would consolidate the ends. We would subtract 4n on both sides. Negative n, negative 1, so n is equal to 1. And that looks like that works. All right, so next up, square, square, cancels, on both sides. I would probably times everything by 6 unless you're using a calculator. If you're allowed to use a calculator for the math, then I wouldn't worry about the math too much. If you're not using a calculator, it might be easier to multiply everything by 6 to get rid of the fraction. You could turn it into a decimal, but I believe if it's over 6, I think that's a repeating decimal. Yeah, I think that's repeating. So probably just better if we multiply everything by 6. So let's multiply both sides by 6, multiply by 6, multiply by 6, 12n. Now it is a little hard to multiply 88 by 6, right? So 8 times 6 is 48. 4, 8 times 6 is 48 again, but we're adding 4, so 5, 2, and a minus, and then the 6 cancels there. That was the whole point, is to get rid of the denominator. So yeah, we had to multiply 6 by 88, but I don't know. Could have been worse. So we want to consolidate the ends. How about we subtract 12n? Okay, so we subtract 12n. So that's going to be negative 11n. And then we divide both sides by negative 11. So n is equal to, and it'd be negative 528 divided by negative 11. Now, it's a little weird doing it that way, but if you think about it, 528 came from 6 times 88. So let's go back to that. Let's just keep it as 6 times negative 88. Okay, which was 528, and then divide by negative 11. That might be easier because then look, 88, 11, they both go into 11. That's 8. 8 times 6 is 48. So sometimes it's actually better to not multiply. the numbers. Just because you can doesn't mean you have to. So actually, it might have been better to just say 6 times 88 and leave it like that. Because then later you divide by the 11, and then you can see, oh, hey, 88 and 11, they both divide by 11, right? So anyways, we get 48, and that looks like that works out. That looks like that works out. So let's move on to the next couple here. Square that, x over 10, 3x minus 58. Now we're going to times everything by 10. So if we times that by 10, it cancels the 10 in the denominator. Times that by 10, 30x, times that by 10. Everything just kind of gains a 0, right? So multiplying by 10 is not too bad. Then we subtract 30x, so we'd get 29, negative 29x is equal to negative 580. And again, you don't even have to multiply that by 10, but it's not that big of a deal because you're just adding a 0, right? So I think if you double 29, you get 58, don't you? 29 plus 29, isn't that 58? Yeah, right? So if I do this, and of course this is me assuming that you're not allowed to use a calculator. If you're allowed to use a calculator, then some of this stuff you don't need to pay attention to as much. You know, it's still good to try to be able to do mental math, right? But, you know, obviously some of this stuff, you know, not as applicable, like some of the mental math that I'm showing you, if you're allowed to use a calculator all the time. So, you know, with a grain of salt. But, I don't know. Being able to do mental math without really having to work for it, I think is kind of cool. It's like you're hacking the system. So, anyways, 58 over 29, that's 2. 29 doubled is 58, so that's 2 with a 0. And that's the answer to that one. Square, square. 3n plus 12 equals n plus 8. Subtract 1n on both sides, and you would have 2n over here. Subtract 12 on both sides, and you'd have negative 4 over there. Now n is equal to negative 2. That should work, but let's plug it in just to be safe. Negative 2 times 3, negative 6 plus 12 is 6. Okay. Negative 2 plus 8 is 6. Okay, we get positive 6 on both sides. We're good. Okay, that actually wasn't too bad. All right, moving on. I think that was a red. So now we should do purple. All right, square, square. N is equal to 2n minus 6. Subtract 2n from 1n, and you get negative n is negative 6, which means n is 6. All right, that looks like that works as well. All right, square, square. 11 minus x is equal to x minus 7. We'd add x to both sides, so 2x. And then add 7 to both sides, so 18. Divide both sides by 2, and you get 9. That looks like that works as well. 11 minus 9, 9 minus 7, both are 2. Okay. So we do it again. Square, square. I'm waiting for where they have... Okay, I thought they were going to have an equation where you don't have a squared on one of the sides. I guess that's going to be the next part. The next part is, well, they'll have a square root on one side, and then they'll have several things on the other side. Gets a little bit more complicated when you have to do that. That'll be for next time, so stay tuned for the next one where we'll cover that. X over 5. I'm going to go and multiply by 5 again here. Just because I'm assuming that you're not using a calculator. If you're using a calculator, not really that big of a deal, but you still want to be careful. Because remember, you still have to type all of that into the calculator. And if you type it in wrong, you'll get the wrong answer. So just be careful. 5 times 72. The trick to multiplying by 5 is actually pretty cool. If you can divide the number by 2 and then add a 0. That's the same as timesing by 5. So let me give you an example. 5 times 6. What's 5 times 6? 30, right? Okay. Now let's try that trick on that. Okay, so take half of 6, 3, add a 0, 30. Oh, look at that. Try it again on another number. If it's an odd number, It's going to be a little harder because you have to take half of an odd number. It's a little bit harder to do, but not too terrible because it's always going to be a 0.5. So not the worst decimal in the world, but it's kind of a cool trick. So if we do that same trick on this, half of 72 is 36. And then we'd add a 0, 316. Right, minus 5x is equal to x. We would add 5x to both sides. So 360 is equal to 6x. Divide both sides by 6. And 36 divided by 6 is 6. So 60. Okay. Square, square. X plus 3. 1 minus x. Add x, you get 2x. Subtract 3, you get negative 2. X is equal to negative 1. Does that work? Yeah, we get 2 on both sides. I haven't seen any extraneous solutions yet. I mean, I'm going to check because I'm curious to see if maybe I missed one, to see if I missed what's called an extraneous solution, but I haven't seen any yet. If this were a test, if I was taking a test and this were my test, I would check all of them for extraneous solutions because you never know. They could try to pull a fast one on you. So always, always check. Highly recommend. Negative 16 minus 2k. Okay, we're going to add 2k to both sides. Subtract 40 on both sides. And that divides evenly by 4. Oh gosh, how many times does that go in? 19? Because 60 would be 15, so it's 14. Negative 14. Okay. Well, actually, hold on. Because that looks like that might be extraneous. Negative 14 times 2 is negative 28. Oh, maybe not. 28. Negative 28 plus 40 be 16. And then the other one, negative 14, negative 28, negative 16. Oh, wait, hold on. Is that even working? Oh, no. That would be positive 28. Positive 28 minus 16. But then that would be 12. Negative 14, negative 28. Oh, yeah, that one would be 12 as well. Okay, I'm tripping. I thought it was 16 for a second. Yeah, they're both 12. So we're good. They both end up being positive when we plug them back in. All right, square, square. X plus 8. 3x plus 8. Subtract x from both sides. Subtract 8 from both sides. Oh, that's 0. So x is 0. But does that make sense? Well, yeah. If they're both 0, if x's are both zeros on both, you get the square root of 8 equals the square root of 8. So yeah, that makes sense. X equals 0 is an okay answer. And even if it was the square root of 0, that's still okay. You can take the square root of 0, but you can't take square root of a negative number. 0 is not really a negative or a positive number. It's kind of like the one number that's not positive or negative, but at the same time, it can be considered positive or negative. It's kind of weird. It's that weird in-between number. So here's the answers, and as I'm scrolling, if you have found this worksheet helpful, give me a thumbs up. But I'd rather you go and get more free helpful stuff. You can grab some more stuff on YouTube, of course, but I also have a ton of free resources on my website, myersmathematics.com. So go to my website, go check out some of the free resources on there. One of the free resources I have on my website, myersmathematics.com, is the 5 math mistakes everyone makes and how to avoid them. So go check that out, go grab that free guide, and I'll see you in another episode real soon.